to Cambridge Chemistry channel with Sarvatana. Be sure to like the video and subscribe the channel. In this video I will discuss 5070 paper 4 alternative to practical May June 2024 paper 4-1. Let's start. Question number 1. A student finds the concentration of dilute acid HA by titration. The student add 25 centimeter cube of aqueous sodium hydroxide to conical flask. Add a few drops of methyl orange indicated to the aqueous sodium hydroxide. Slowly add HA to the aqueous sodium hydroxide until the methyl orange changes color. Record the volume of HA added. Figure 1.1 shows the apparatus the student uses to measure 25 centimeter cube of aqueous sodium hydroxide. Name the apparatus shown. This is measuring cylinder. Name a more suitable apparatus. Piece of apparatus to measure 25 centimeter cube of aqueous sodium hydroxide. It is pipette because pipette is most accurate than burette. Pipette is most accurate than burette, and burette is most accurate than measuring standard. Please keep it in mind. Now figure 1.2 shows the apparatus used to determine the volume of HA at the end of the experiment. Name the apparatus shown. This is burette. The initial reading on this apparatus is 1 centimeter cube. Use figure 1.2 to determine the volume of HA used in the titration. This is 23.6 volume of HA. The student washes the apparatus figure 1.2 before it is used. State the substance used to wash the apparatus, acid which is taken afterward in the burette. Describe the color change of the methyl orange at the end point. The color, because sodium hydroxide is taken in flask, so color in flask is yellow. So when we add acid, the color change is pink. So it is yellow to pink because pink is an acid. A student investigates the reaction of 4 metals A, B, C and D with aqueous copper 2 sulfate. 4 metals are all gray solids. The student puts 25 centimeter cube of aqueous copper 2 sulfate into beaker and measure its temperature. Record this temperature in table 2.1. Adds a sample of A to aqueous copper 2 sulfate. Stir the reaction mixture until adds a sample of A to the copper 2 sulfate. Stir the reaction mixture until there is no further increase in temperature. Measures the highest temperature of the mixture and records the temperature in the table 2.1. Observe any changes in the appearance of the mixture in the beaker. The student repeats the experiment 3 more times using B, C and D instead of A. The results for D are shown. This is initial temperature for D and highest temperature for D. So this is the initial temperature 21.0, the 21.0, and the final temperature is 53.5. So by subtracting the highest temperature from the initial temperature, it is 21.5 and this is 32.5. Now state the value in table 2.1 which the student records to an incorrect degree of precision. This is 20 because temperature is 0.01 decimal place, so this is wrong precision, though instead of 20.0 it is written as 20. The temperature for D are shown in figure 2.1. Record these temperatures in the table 2.1. Calculate and record the temperature increases for B and D in table 2.1. The equation for the reaction between B and copper 2 sulfate is shown. Copper 2 sulfate is blue solution. At the end of the experiment, the student observes a colorless solution. a gray solid, and a brown solid. Explain how these observations show that B is in excess in this reaction. As gray solid, B remains in the flask, in the container, and which is unreacted. Using the equation in 3, write the formula for colorless solution: gray solid, brown solid. Colorless solution is BSO4, gray solid is B, and brown solid is copper. Use your results to arrange A, B, C, and D in descending uh, order of the reactivity. Explain the results. Give this order of reactivity. Most reactive is there is greater temperature change. For A is the greater temperature change, then C, then D, and then B. So the first A, C, D, and B. The greater explanation is the greater temperature change, the more reactive the metal is. A student repeats the experiment using a fifth metal. This metal is the second most reactive of the 5 metals. Suggest a temperature increase for this experiment. So A has the maximum temperature change is 49.5, so it should be in between 49.5 and 39, so it can be 45 degrees centigrade. The temperature increase measured are less than the true values for these experiments. Suggest reason for this. Describe an improvement to the method which makes the results closer to the true values. Reason that the heat loss and improvement, we should choose polystyrene cup, which is a good insulator. State and explain the effect of using half the concentration of aqueous copper to sulfate on the temperature increase for metal A. It will lower the temperature or decrease the temperature. Explanation: temperature is decreased to by half in each experiment by decreasing concentration as less copper ions to react. Question number 3. A student does a series of experiments to investigate solution R. The student leaves a wooden plate with one end dipped into R for 10 minutes. The student then places a damp end of the wooden plate into the blue Bunsen burner flame. The flame briefly shows a shade of red and then turns yellow. State 2 possible conclusion from this observation. So this is lithium and calcium ion might be present. Explain why it is difficult to make because the color of lithium is red and calcium is yellow. Why it is difficult to make definite conclusion from the observation in A1. Different ions give similar result or color, so that's why. The student adds dilute nitric acid to R followed by aqueous barium nitrate. Dilute nitric acid, then barium nitrate. The student concludes that R does not contain sulfate ions. State the observation which allows the student to make this conclusion. So for sulfate ion, for this test, sulfate white precipitates are formed, but there is no change. White precipitates are not formed, so colorless solution or no change is there. The student adds dilute nitric acid R followed by aqueous silver nitrate. The student observes a white precipitate R. State a conclusion from this observation. So R contains, if white precipitates are formed by this test, so R contains chloride ions. The student adds aqueous silver nitrate to aqueous sodium carbonate. A white precipitate forms. The student adds dilute nitric acid a drop at a time until no further changes in a white precipitate dissolves to form a colorless solution. So carbonates, silver carbonates are formed, white precipitate and sodium nitrate, which is the aqueous solution. So when we add dilute nitric acid, so effervescence of gas can be seen. Suggest why it is important to add dilute nitric acid and C to prevent ions other than chloride forming white precipitate. The student adds a few drops of aqueous sodium hydroxide to R. State the observation the student makes, which suggests that R may contain calcium 2 positive ions, so white precipitates are formed. Describe what else the student needs to do. confirm that calcium ions are present. State what the student observes. What the student does: add excess sodium hydroxide aqueous and white precipitates remain insoluble. It means calcium ions must be present. The student warms a solution from E. Uh, the student concludes the ammonia gas is produced. State the observation the student makes which confirm the ammonia gas is produced. Gas turns damp red litmus paper blue. Identify a cation other than the calcium present in R. So it means if gas turns damp red litmus paper blue, it means ammonium ions are present. Solution R is made from a mixture of two different ionic compounds. Suggest the names of these two compounds. That could be because calcium ions are confirmed and chloride ions are confirmed over here because white precipitates are formed. So it means solution must contain calcium chloride and ammonium chloride. Barium carbonate decomposes when heated. The word equation for this reaction is shown. Barium carbonate to form barium oxide plus carbon dioxide. Plan an experiment to determine the percentage loss in mass when barium carbonate is heated. Your plan must include the use of common laboratory apparatus and a sample of barium carbonate. No other chemicals should be used. Your plan must include the apparatus needed, method to use, and the measurement to take. Procedures to ensure that percentage determined as accurate as possible. How the measurements are used to determine the percentage loss in mass. You may draw a diagram to help answer the question. Weigh the crucible with its lid. Transfer and weighed mass of barium carbonate into crucible. Weigh the crucible along with barium carbonate and lid. Place the crucible on the spirit lamp. Heat the crucible gently with loosely lit for about 1 minute. Then heat the crucible strongly without the lid for further 4 minutes to ensure all gas escape. Leave the crucible and its content to cool with the lid on for several minutes. When the crucible cool, weigh it with the lid and contents. Repeat the experiment and take average loss in mass. Calculate and record the mass of the content and the mass of carbon dioxide lost and calculated the percentage lost by using loss in mass is equal to initial mass minus final mass, and percentage loss in mass is equal to loss in mass divided by initial mass into 100. And we can use this diagram. This is crucible with lid, and in this copper 2 carbonate when heated gives copper oxide and carbon dioxide. This is loosely lid placed over here, and this is spirit lamp. This tripod stand with wire gauze. So this is all about of this paper. Hopefully you understand this paper, and if you understand, like the video and share it.